On example 5, it says the table shows the total number of pieces of fudge sold over the weekend from a store. Make a graph of the data to show the total amount of each type of fudge bought over the weekend. So we're going to add another column like we did before, but this time it's not going to be cumulative. It's just going to be the total for each category. And question, is this going to be a bar graph or a histogram? This is going to be a bar graph, hopefully you said, because these data are categorical. They're not numerical. So I'm going to make this column. I'm going to call it total. And now let's add them up. If I take 111 plus 145, that's 256. 256 plus 20 is 376. We can use a calculator, probably easier than I did that, but I want to add when I can. 100 plus 90 is 190, so that would be 266. 67 plus 82, that would be 149. Plus 90 would be 139. Try 239. Sorry about that. Let me double check that again. 90 plus 82 would be 172. 172 plus 67 would be 239. Okay, next row. 90 plus 65 plus 83. If I add 90 and 80, or if I add 65 and 83, I'll get 148. Plus 90 would be 238. So those are very, very close, aren't they? And then our last one. I'm just going to use a calculator on this one. 85 plus 77 plus 78. And you get 240. Now, here's what we're going to do. We're going to make a bar graph. Except I'm not going to start at 0 this time. Actually, I take that back. I want to start at 0 because I was just thinking that would be kind of misleading. So we're going to make our bar graph. So we're going to put chocolate for 1 bar. And then chocolate walnut will be the next one. And then we'll have chocolate peanut butter, maple walnut, and peanut butter. Now, how are we going to scale our graph? Well, our biggest number is 376. So if I take 400 and I divide that by 10, I get 40. So I'm going to count by 50s. And now, let's just graph this. So chocolate is 376. Chocolate walnut is 266. Chocolate peanut butter is 239. Maple walnut is 238. Those are practically the same height, aren't they? And peanut butter is 240. And there's your answer, or that's the process of making that histogram. Now let's take a look at example 6. It says the table shows the different temperatures of 6 high school students that came into the nurse's office in a week. Determine whether the data is discrete or continuous. Then make the graph. So is our data for temperatures that discrete or continuous? Well, I would say this is continuous. It's continuous because they're not categoricals. Your numbers just go all throughout. So let's look at our chart here. And if we take a look at here, 98.5, I'm looking for the smallest, 98.4. I'm going from 98.4 all the way to 102. So I think I'm going to count by ones. Does that make sense? Because we can fit them on there. That's the key. So 98, 99, 100, 101, and 102. Now this is kind of like a dot plot. We have to figure out where we're going to put our numbers. So let's make a table here on the side. So 98.5, put a tally mark there, 99.2, 101.1, 100.7, 99.1, 98.4, 100.7, 102.3, 101.2, 100.3, 99.7, 100.9, 98.7, 99.2, and 99.9. So our biggest tally is 5. So we'll put our frequency up here. 1, 2, 3, 4, and 5. Remember, we're making a histogram, so they have to be connected. So 98, there's 3 of them. 99, there are 6 of the 9. Whoops, I got to go up to 6 then, don't I? No, 5. I can't count. Up to 5. 100, there's 4. 101, there's 2. In 102, there's 1. And there is your graph.